Yoo-hoo! Starting as soon as I wish. So right now, I don't care. Hello, everybody. Sorry for not being here 2 days ago, but I'm sure no one noticed because I always have 0 viewers, and the time I have 1 viewer is a bot that's trying to sell me on X some VTubers materials, some stuff like that, and I don't really care. So that's it. We will start now. I didn't start the development environment actually, but just stay with me. I'll do it in a moment. Docker desktop is already running, so no, this is not the right thing. That was the terminal for when I study Handmade Hero, but I'm not studying Handmade Hero tonight. I'm not studying that. I'm developing our beautiful e-commerce, which is this one. So again, Docker compose up, which starts everything, the server and well, the server and the database. And today I finally bring my my other laptop, the one I had Linux installed on, to the repairman, because it's a long story, but in short, the laptop freezes, and the only way to stop it from freezing is to start without ACPI, but that means it's working just on one core, no thermal control, no nothing, and it's slow as hell, and probably it's not so healthy for the machine as well. But I really couldn't understand what was going on. No singular, no particular pattern in error logs from one crash to the other. There wasn't anything pointing towards a specific problem in software. Also, the same issue, I had it with clean installation with the boot from the USB key. So yeah, probably some hardware problem or some misconfiguration problem. Maybe a damage from too much heat, because maybe ACPI wasn't implemented very well for that computer. And in fact, I found a warning notice in the instructions that say that that computer is not that does not support Linux. You know, you buy a machine from Asus, and the machine says, yeah, well, actually, I'm only developed to work with Windows, which may be some way to stay out of court if people have problems and they install Linux. They say, we just tested it for Windows. Maybe they know pretty well that they didn't implement everything they had to implement in the ACPI, which is wait a sec, no, wait a sec, we do this and this and this and this, and I show you what is the ACPI computer. The ACPI is the Advanced Configuration and Power Interface, which is a fancy name for the new BIOS, okay? Because the BIOS, I don't know how to pronounce it in English. I always said BIOS in Italian, is the part that sits in hardware on your computer, is the part of software that sits in the hardware of your computer that's not implemented by it's implemented by the manufacturer, but and then handles the control to the operating system, but the operating system has no control whatsoever on the things that the BIOS usually controls. So fans, I guess, also other kind of sensors like thermal sensors. I'm not an expert on this, but that would mean that if your computer was a human, it would have been a human with a functioning brain, but that doesn't feel heat. If heat is applied to the hands, to the fingers, something like that, and the only way for the body to counteract the heat was to have a short circuit between the sensor of the heat on the thermal sensor on your finger and the muscle on your finger, which actually happens even in the human body. If you get burned, you will take the hand away from where it burns before the conscient self, you, understand you've been burned, because the signal has to travel all the way up to the brain and to be processed for you to be conscient. There will be a part of a brain that's aware of that before you to be conscient, but the reaction comes even faster, because you have neurons right in the spine that are the first computational center that the signal reaches from your hand, and that is directly wired to control to some extent your muscles, and you will move your hand. And having the bias and not having a way for the operating system to know the status of your thermal sensors and fan speed and stuff like that means that your operating system cannot know how hardware is, in which state it is, meaningfully the physical hardware, if it's too hot, too cold, if the voltages are okay, so that throttling wouldn't be a thing. Throttling is controlled by the operating system. I think it is, or maybe, because when you set this, look at this. Power mode, plugged in, best performance, or better battery. This thing here requires you to have ACPI active, because if not, how can the computer tell the hardware, which has hardware devices to do stuff, do less? Okay. Also, you have to measure what's going on the battery. That's a sensor. Okay. And let's see, throttling. Is throttling also implemented in the OS? CPU throttling is implemented. Yeah, where in the CPU? Because if that's true, the hardware has it has the possibility to defend itself, but overheating leads to throttling to prevent damage to hardware. Throttling affects gaming. I'd say there is a hardware system which is there, so even if you're lazy, even if you implement something that's melting your CPU, the hardware will always have ways to defend itself. Yeah, when your CPU reaches its thermal limits, CPU throttling kicks in to prevent overheating and potential damage. I'd say that this is not up for overriding from software implementers. Yeah, but still, you can throttle even more, and that must be controlled by the software, because I have a slider here, and this works. I mean, if ACPI wasn't a thing, you couldn't do that. In fact, ACPI is an open standard that operating systems can use to discover and configure computer hardware components to perform power management, auto configuration, and status monitoring. Aims to replace APM, the multiprocessor specification, and the plug-and-play BIOS specification. brings power management under the control of the operating system, as opposed to the previous BIOS-centric system that relied on platform-specific firmware to determine power management and configuration policies. This thing came to life, here it says first published December 1996, but I'd argue that many of us started having to the feeling that something changed in the operating systems. What? In the operating systems in the middle 2000, so 2005. I mean, I don't remember XP having anything like this, but I'm pretty sure Vista did and Windows 7 did. So if ACPI is poorly implemented, because again, ACPI allows the operating system to talk to the hardware, but it's still implemented not in the operating system. It's implemented in the hardware, of course, because it's an API for the operating system to call to know what's going on the hardware level. In fact, you can see that it also has an ACPI table, which was probably fucked up, if you ask me, on my computer, because that's something that I saw. There was some message. Oh, right. Actually, in the end, it turns out it was just something that was more like a warning or a notice, but many other people found something like that, and someone even had the nerve to go down and change it. You must be a pretty good programmer. It must be a pretty good have a pretty good knowledge of how to interact with the hardware to do something like that and swap the ACPI with a better ACPI, better implemented, because this guy was pissed off with the log errors dumped by the fact that during the boot I don't remember the name. During the bootstrap of the system, it dumps these warnings in the log. He says people were lazy. The ones who implemented this thing, they left stuff in a status that has this as a consequence. I will fix it, and they fixed it. But I'm digressing. I remember this. There was an image here somewhere. Look at this. Wait. Operating systems. No. There's an image that perfectly ACPI images. Here it is. OS kernel. The kernel talks to the ACPI driver. There is then the actual ACPI that talks to the hardware. So these are, as you can see here, OS independent technologies, interfaces, code, and hardware. It's on your motherboard. It's on your motherboard, like the BIOS itself, but unlike the BIOS, it's to some extent controllable by the kernel and the OS. So if this stops working, you may have a hard time. I'm suspecting that my ACPI wasn't properly implemented, that Linux wasn't controlling the hardware correctly because of that. Windows would have done that pretty well, Linux didn't. The reason for me being happy that under Linux my computer was more silent was because probably Linux wasn't as aware of the temperatures going on. In fact, I found that my CPU was running a little lot high, more than 90 degrees at that point, which triggered me to change the thermal paste, and then suddenly it was 60 degrees. So I mean Celsius, of course, not Fahrenheit. And so I could probably be looking at a brick because probably something just burned because of sustained stress, thermal stress. We will see if the technician says that's the case or not. I don't understand why the stream preview won't show me. Please show me. I want to check if everything's all right. Seems all right. Everything seems all right. So let's begin. Let's begin by saying that I want to go to localhost index, and this is broken because I was trying stuff with the CSS last time, but we can fix it right now. Let's go to not include HTTP docs, no, not even HTTP docs, index.php, and here we have this, which, yeah, perfect, and this is it. So we were left at the fact that here now we can upload for the first time. Oh no, they're all, yeah, wait a sec. Let's add it to the cart. Don't look back, go to the cart, delete it, go back to the shop, go here, and I can show you that I can upload an image larger than 8 megabytes, which was the default limit for PHP on post, and also on every other. You couldn't upload more than 8 megabytes at one time. Now this one is 9.70 and it will upload just fine. No. Yeah, this is not a problem. We already experienced that. This is me leaving a log debug call somewhere, and I will just dump it right now. Cd git result grep -r log debug, passing here in display case, which is exactly what we don't want. Display case log debug, which is using a socket to talk to another process which is not here, so it's throwing, but actually is a warning. You can see it's a warning. File get contents docker internal 4000 failed to open stream, so nothing to worry about. The image is here, and I will show you that, because doing like this again won't actually raise any warning anymore, in fact. And then you can swap the image for another image like this. Okay, that used to work even before. Again, global, where is that? Multiparse form data. I have some other calls to that for sure. Look at that, multipart form data. I left the how do you call it, the code base in a miserable state last time. Oh no, this wasn't what I meant. Actually, we could, I don't want to delete those because we didn't finish the work here. I will just start the process that listens for the calls and call it a day. Scripts and start logger server, which we already discussed, is just something that receives requests and prints them here in the console. So I have console in PHP like a sane language from the 2000s. So again, let's say we switch this picture, and I'm suspecting that we have another issue. Yeah, undefined variable parsing body. This one is worse. In fact, you can see that fgats here it's broken. We didn't finish to fix this thing, and we were talking about the fact that here, down here, there's fwrite, fgets. Yeah, we were trying to do this where you get, instead of getting lines, we were wanting to get chunks of the stream, and those should be small enough so that you process a manageable part of the stream of the file every time it comes in. Then you dump it to the file on the file system in the server where you want it, and then you get another chunk of the stream, etc., etc., etc. Before we were doing that line by line, which we could actually do again if I just for demonstration purposes. I didn't have the time to fix this thing, so I am sorry if it gets confusing. I don't want it. You just cover your ears during this part and wait for it to work again, and then we will see from the interface, from the user interface, how it's supposed to work. Is it right though? Let me do this. No, you have to go all the way to the back because you are annoying and obnoxious, and I don't want you. And here we'll get diff. That was CGI bin with, what's it called, multipart. It's not in CGI bin, not even once it was. fgets. Yeah, it reads a line, so it should be fine. I hope. Let's see if it's fine. Undefined variable stream. Yeah, of course. Line 23. Yeah, I mean, he's not right. He's not wrong. Stream. Probably the static analyzer would save me some time here, but I'm just, yeah, no. Must be of the type resource bool given. Why is that? Read from stream. Reading part body. Yeah. So, sorry, that's not gonna cut it. We will go like this, put data. Which means, oh, well, let me docker exec minus it resulto bash vendor. Oh no, right, because we have it here, vendor bin php stan. Do we have it? Yeah, analyze. We don't have it. Yeah, we should have it. PHP stan. Is it installed? No, I guess I didn't, and that's a pity. Let me see. Yeah, it's installed. Okay, so it's just the autocompletion here that's not working. PHP stan analyze, which should be written like this if you want to be friend with Americans, but I don't know why my hand just learned analyze with an S, and so welcome UK. Oh my God, memory limit. Probably when I'm talking so much, less oxygen is reaching my brain and I start to yawn. I'm not that bored by the thing I'm doing, actually. And the file is multipart form data.php. Permission denied. What the really? That's why it wasn't working. Vendor bin. Yeah. Change owner to root sudo. on vendor. Yeah. I mean, oh yeah, I think I copied this thing over, so probably the fastest way to make it work correctly, because I'm I don't know if it's a good idea to change it. Well, actually, I could do this. Look at me. ll doc footy include vendor. Yeah, it's all root, so yeah. Also bin. Yeah, so I will just do that. Change owner, sudo change owner -r, which should be recursive. Root on vendor. And this is one thing, and then change group, same stuff. And this should be it, I guess. Where was I? Here. Permission denied. I hate you, mother. ls vendor ls minus al also. It's not executable. It's not executable, right? And so change mode plus x vendor bin php stan, and this should do the trick. Yeah. Read from stream, head parameter stream with no type specified. Yeah, I know. Which is here, and the stream should be of type what did it say before? Resource, something like that. I don't usually handle this kind of stuff directly, so there was an error before. I don't remember in which page though. This one, resource. Yeah. Look at this, resource, and that will surely break everything. I don't think it's fine, because usually highlighting works perfectly, and yeah, well, I was right to say that we need something like use resource, but still I don't think it's has invalid type resource. Sweet mother of God. Expects resource given. I love it. What can I do? I could just inline it again, like this, and call it a day. Is it okay? Yeah, I don't care about that. There is they're complaining about f gets to. Let's say we go up here and comment this. This is not influencing that, right? Oh, no, wait. It's talking about this, so yeah. I thought it was talking about this f gets here, but actually was talking about this, and it was complaining that resource that was shown here was not the right resource, so I don't care about that. No type specifies, should return string but returns null. Yeah, perfect. So again, another try. Let's give it another try. Yeah, it works. As you can see, apart from this, which I don't care about, and I don't know why it's printing it. File submit. Okay, I will check it. As you can see, okay, I remember now, actually. As you can see, when I upload an image to overwrite an image that's already there, it's actually using, as I told in the last two streams, actually, it's using a put instead of, where is it? Here. It's using a put call instead of a post call. And long story short, put is not supported by PHP natively, so we had to do it ourselves. This code here is what reads the content of the body here, which says binary actually, so you can't see it. It's somewhere here, but for some reason it won't render it, not even saying binary. It's simply not visible. So from the point where it starts, the binary starts, which is after the header, after one empty line, then there's the binary, up to the end of the binary, you have random binary data. We had this weird bug where if two dashes were happening in the binary, which is totally possible, it just hell broke loose and we couldn't read the file up to the end, and the system was complaining, errors, stuff like that. Now it's working, and it's working even if I upload if I put an image that's more than 8 megabytes, which is this one, as you remember from before, 970. So if I pick this one and go like this, it worked. It used put, you can see here, and it's actually also on the server, which I can show you if I go here and then here and then and then it should be in upload. And there are a lot of files because these are the previous uploads I made, and it should be one of those that's more heavy. So one of these, but you can see I did it multiple times. So the latest, it's now it's 6:30. This one should be the one because it's the 6th of June and it's 6 p.m. 6:30 p.m. here, so it was 1 minute ago. This one is the picture, and we could open it with I know Krita is a little bit slow, but we'll do paint. Let's say paint. Magic gonna happen. Is magic happening? Magic happened. It's here it is, loaded. But to get back to our to the business, back to business, we now have to say, yeah, this method is not nice because, you know, fgets will give you a huge string, possibly huge, because until there is a new line in the image, it will just vomit data. It will just vomit a lot of bytes. We saw the last time that a line could very well be bigger than 1000 characters, which is, in that case, is not too much. It's 4 kilobytes, but you don't know. If you are very unlucky, it could be several megabytes. That shouldn't be a problem for this system in particular, because we are not allowing in this moment images that are bigger than 16 megabytes, but I would like it to be future-proof. I would like it to work well below the 128 megabytes limit for the PHP footprint in the random access memory, actually. So the better way to do this is to dump fgets and go with stream get line. Stream get line is actually not doing what it's promising to do. It's not getting a line. It's getting, if you say 0 here, we saw it from the documentation last time, it's getting a chunk, and that chunk is a standard size. Look at this, stream get line PHP. Stream get line length if reading ends with when length bytes have been read, when the non-empty string specified by ending is found. So if you let it be an empty string, it's not gonna use the character you didn't specify actually to check if the line actually ended. So string get line actually does that thing that it can do the thing that it checks for the end of the line and then returns the chunk of the string corresponding to a line, depending on the separator between lines you specify, because you may say that to me a line ends when I find a break at the end, so a tag BR as in HTML. Who knows? This is configurable here. Or it's just a new line, or is a carriage return plus new line. Who knows? If you don't specify this, then it stops when the length has been reached. If you don't specify a length, or better, if you specify 0 as a length, wait. If it finds an end of file, it will return. So that's the absolute maximum you can get, the further you can get. But if you put 0 as a length, it will try to take out the default socket chunk, which is this amount of bytes. Now, the thing is, we want to say, go with the fgets, the regular fgets, the moment we start, because you know the request, where is it? Not here, not even here. Why do I have this page open here? Let's go. The request always starts, the payload actually always starts with the separator and the headers and the new line. So up until that, up to that point, we are very confident that these lines are not a problem for our memory. They are pretty short, very sweet, everything's fine. Let's get going with the fgets, because it's more comfy. You don't have to do as much work, manual work in parsing, as you have if you do the other way around. But the moment you start reading the bytes, just go with the standard socket chunks and stop when you find this. Since it will stop when you reach the end of the file, you could either have this thing completely inside the last chunk, or you could have this thing split in half by the last boundary between two chunks, meaning that the n-1 chunk ends up here, for example, after form, let's say, or after the n of boundary, okay, and then a chunk of the standard socket value, and then after the n you just get a very, very small chunk. So the naive way to solve this problem would be to how do you call it, to check every time if in the chunk you are getting in there is this part, this string, at least the beginning of this string, okay? We have a problem with that performance-wise is not a good idea, because the file could be several megabytes large, and you would do this check, which I'm not confident is very performant, many times over before getting to the end of this. There is a better way, which is extracting from the headers the content length. Knowing the content length, you know very well when you're towards the end, and so you start how to say, worrying about this just when you get to the end. So what we were doing was to make a kind of state machine, because we were saying that read from string is a thing, and when the string starts with, well, actually, if let me zoom in for you, because if not, you can't read anything. If I'm reading part headers, we could very well get rid of read from string, actually. And this could be a do while. Is there the concept of a do while in PHP? I never used it. Probably not. Yeah, there is. There is. Okay, perfect. I guess this is the syntax. Let me see. Let me see. No. I want it. I want this one. Yeah, I was right. So if reading part headers actually I was thinking give me a sec, because first of all, we would like to extract from the headers the size of the content we have to read, and I'm pretty confident that this refers that's for sure. This refers to the entire body, comprehending the headers and the separators. So let's say that if reading part headers else, actually we need just one boolean reading body, reading part body, because we could extend in the future the support to multi-part reading part body. If not reading part body, let's say we want to get rid of the first line before. We know that the first line will start with this boundary string, right? Look at this. We have content type. We could pass, let's say later we will pass int content length, because we will use it. So yeah, well, that log debug is good there, and we are fine with it. Initial boundary is this one. If we are not reading the part body, we are pretty confident that the first time we get a line, we will get a line that starts with this. Let's do this. Boundary. I will go the incremental way, which is the way I like. So I will say this. Let's say we totally ignore the fact that this was working. Okay. Those comments never work the way I expect them to work, but that's not an issue. Yes, it is. Well, Let's do this. Let's do this. An early return won't hurt. Old code. Now, parts. Yeah. If not reading part body, let's say we do this. F gets on the put data. This will be the first line, and we log debug the first line. So let's do this one more time. Sorry. Let's do this before. Syntax error online. Yeah, well, what did I expect? 57. Of course, while false. Expecting on line 65. Well, that may be the same error manifesting itself in a different way. Yeah, it was like that. So if I do this again and I load a different image, because if not, yeah, too few arguments. Oh, God. Why do I want to implement 3 things at a time? This is used in include, not really, SRC preprocessor, I guess. Yeah, multi-part form data get content type. Also content length, which must be retrieved. Content length from headers, content length, and this should do the trick. Please let me go on. Tell me it does the trick. Yeah, it's a string. Yeah, of course I have to parse it. Tac. No, it's not working the way I meant it. Boost split, vertical split, SRC preprocessor, and here this is casted to int. Much better. Much better, because I guess now we have something here. Where is it? Yeah, I think this guy here was new, but I'm not sure, so we will do another round. First we need to new very obvious message. Let's go. Yes, yeah, let's go. My ass. Here. Let's see. Okay, it's doing what I meant. You can stupid. I don't know why I actually is right. First line is first line, and it's exactly the same of initial boundary. So we could do something like this. Let's say if first line equals initial boundary, everything's fine, else we can't trust anyone anymore, which is short for to do implement error handling. The message does not comply with the standard format. Well, this is okay. So at this point We don't care about error handling at all. We're implementing our prototype right now, so we're gonna go down to the with the happy path and let the to-do remind us later. If not reading part body, which is true because this one is not necessary anymore, we could actually make it a little bit better. Let's say state reading headers. If, and this is the time for us very nice old school switch parser state. What am I doing here? Case reading headers, and I will probably regret the thing I did with the first line when I will, well, I won't worry about this now, but I will regret it the moment I well, maybe not. The moment I try to implement the multi-part stuff. Reading body. Break. Default. To do programming error. Raise, throw an exception or something. I won't do it now because I want to be. I also want to be sure that there's something catching such an error if I'm throwing it. So not now. Oh, sorry guys. 10. I swear I'm having a lot of fun, actually. This is the part of the work, of the job that I love the most. That's the part you are less and less able to do because no one wants to pay you to do this, and you usually just install some framework or library that handle this thing one way or another, or just go down the path of least resistance, which would have been replace put with post and live with it. But I'm kind of a stickler, and I have the opportunity to do this what I think is the right way, because I want to be able to make this a reusable piece of code that I will use in the future as well. And if I'm gonna design a public API with this thing, I must allow people to upload files with put, because put is the way HTTP meant you to replace stuff. There's put and patch, but put replaces the entire thing. Patch replaces a part of the thing. The name says it by itself. Patching is putting a patch, a stripe of cloth on the hole in your jacket. So, case reading headers. We are reading headers, so we are very, very happy with fgets. So we will keep fgetting the data that reached us through the put method. And this is a line, I guess. Now it's time to close the preprocessor and split this file and go look at the old code. What we were doing before was let's look at that. First of all, we were creating current part new multi-part form data part. Let's copy this over. Let's not be stupid and let's copy it. Text plain. Okay, everything's fine. So that was the thing. Then reading headers. We get the line, which was done in the while statement here before. So we must do it this time. Get the line. Actually, it was called chunk there, but before it was called line, and line is the right name in this situation. And let's say if line equals this, I'm very curious to know if the carriage return is always there. I'm very curious. For the moment, it's working. To do will /r always be there. I'd say yes, because I think I checked the documentation of the format that time, but why are you broken? Okay, I know why. Because Vim also has problems from time to time. This just says that we have to stop, change the state. Parser state reading body. We move to the next state. Then if the line is something else, which could be anything else, we are reading the headers. So header parts explode line header parts. I'm dyslexic when I'm live. Header parts 0, header values trim, header parts 1, header value parts explode, header values, and here we are. This is just exactly the same we had before. The line is made of parts that are separated from by columns. The header name is the first part. The next part contains the values, but also the values are divided in different parts by semicolons. And now you have this. If we didn't set headers for the current part headers, if there isn't in headers any header with that name, we create one. Yeah. And then we load it with what we find. I must show you what we're parsing so you understand this. What we're parsing is this payload. This thing. Look at this. This part here before the colon is the name of the header. This part after the colon are the values of the header. So we split this line in two, took the name, said, do we have anything with this name in our array, we don't. Okay. This is made so that if for some reason there is another line which says content disposition, we won't override, we will add what we find to the previous one. But I don't expect it to happen actually. Then the second part is semicolon separated, and every single bit is put in the array that has for key this name. So content disposition will be a key in the headers array, and every array the array associated with the key content disposition will contain several strings. One will say form data, the second one will say name equals space, or probably we also split this, but I have to check. Maybe later, maybe we do it down the line. No, we do it here. Look at this. For each, actually we don't. We just take the value as is. So name equals base graphics write file. I guess we'll see here. For the moment, it's just added. Then what it is done if header name this should be happening inside here actually, and this guy here, well, should be here. If header name equals content type, I'm checking just to be sure that the thing that I'm copying over is correct, right? Because the moment you change a part of it, you're not sure the part you changed interacts so well with the part you didn't change. Maybe the part you didn't change, actually in this case it should work. The part you didn't change interacted with what you changed in some way, so now that you changed it, you are introducing a bug. But it's probably fine because we are still getting a line here. So let's say it's for educational purposes. Current part meme type. Well, if it's content type, we you see it's taking the headers are set in there unprocessed. I mean, yeah, they are processed, but we just separated the parts by exploding on the semicolons, and that happens here, and here we put the parts in the headers. But then we extract some information, because if the header name was content type, we say wait, content type will have something here, and that something is the meme type of the picture we're uploading, because we're focused on pictures of the file we're uploading. So we create some object, because I had my way to parse meme types and stuff. So we create a meme type by taking the first element we saved in headers, because here there's no semicolon, so we get just this part. So in the header, which key is which has as key content type, the first element will be this string here. So we take the string, pass it to meme type create, and then we set the meme type to the current part we're parsing, the object here, the multi-part form data part. Then, what do? We say content disposition values. Content disposition. Because content disposition should come first, right? So, content disposition values, current part, headers, content disposition. I guess I checked. It's always content dispositions, content type. Let's make sure. You see subpart or multipart body request header. Is there actually it should be this. This is the web API. I don't sending and retrieving form data. Understanding HTML, basic knowledge of HTTP. God, you're making it way more difficult than it's needed. This one was a bad search. This one is a better search. Understand? Yeah, I don't trust you. Is there? Yeah. No. There must be a specification, and I'm confident it is on W3C, but yeah, the RFC. Proposed standard errata exists. I don't. The ultimate guide. Is it the most recent one? RFC 2388. I guess it is. I'd say is the one. Posting. Oh, well, you know what? Let's look at this. I don't want to fall down this hole right now because, you know, here you see it could be on 2 lines. Well, actually, this is just an example. Multipart response body, content disposition form data field. Well, let's go on. We don't have all the day. I will check it off stream. I don't want to bore you more than this. Handle malformed request. No, well, where were we? Content disposition values. Yeah. Values. We looped over content disposition values, and if we found the name, because, you know, here it is. There's the name here. We exploded the this in two parts. The first part was name, the second part was the value we were interested in. So we took the part we were interested in and put it into name, because we expect the parts to always have a name. There's also the file name here, which is handled where? Down in content disposition. Is handled in content type. Why? I could very well do it here. There's no reason for that. Yeah, I don't. I really don't like what I did here. This is stupid. This is very stupid. Yeah, you see, it was good to check it, because it's stupid to work with content disposition values when you're working on the content type. So there was no reason for that. So let's say if header name is instead content disposition, what you do is assign to content disposition values wait a sec. Yeah, right. You go to headers. You know what? I really don't like this way of doing things. Well, because you're first looping over the values, then you're looping over the values again. But I guess it's fine. Yeah. Okay. You still have to explode them though. No. Sorry, they are already exploded. Yeah. So content disposition values. I'm wondering if we could do this already in the for each, but no. Let's leave it like this, one step at a time. So let's say content disposition values could or may not contain an equals. Okay. So I don't know if I did this. You see here, what I do is to say, let's take a substring from 0 to 4 of the value, and if it's name, it means we are looking at this guy here. Notice that we trimmed the string before, so this space here won't be there. So we are looking at this. So then we explode on the equals and take out this and this. But I'm wondering if it was better. It's probably the same performance-wise, even because it's kind of 2 lines and then we have to pump megabytes of data, so it's totally negligible. But I'd rather do this. I'd rather do if something like there is string contains, yeah, and we pass the string, which is content disposition values, and we ask it to check. Actually, there's haystack and needle, or needle haystack, I don't remember. Probably it's haystack needle contains, and this is it, haystack needle, right? So I did the right thing here. Content disposition. If there is an equal inside, we explode the string on the equals, and so it's equals, and then it's content disposition. Actually, we should have been looping over the values, content disposition values as content disposition value, and then this content disposition value, right? We explode it. We have content disposition value parts. Name part, content disposition value parts 0, value part content I mean, why don't I do this, which is way better? And I'm behind myself, right? Yeah, I was coding behind myself. I have to remember that I'm there. I'm down there. Now that we have the value, the name and the value, we can say that if name part equals name, we will do one thing. If name part equals file name, we'll do another thing. So if name part equals file name, we will do another thing because we are parsing. We will not care about this. We will just skip it because I guess we did that before. We don't care. It's form data anywhere, right? Yeah, we don't. But if it's name, we want to save this thing here inside this member. So we will do this current part name equals trim value part, and we will trim away the double quotes. Otherwise, current part file name, right? Original file name, which all of this will go down to name will be used. It's a key so that I know which element I'm changing, I'm updating. And original file name is the one that you saw in the previous streams that I put in the database so that we can display to the user the original file name again. So original file name, trim, value part, same thing actually. Oh, actually, we could do this value part. Yeah, well, we don't know if it will always be there. So why did I leave this space here? I hate it. Okay, so this is way better. And here it breaks. As to say, we don't care about other values. I won't break. I won't break. Let it go up to the end. If is null, current part name, malformed request. Yeah, this is strange. Well, no, strange. I was drunk. So if there is an equal in content disposition value, I mean, yeah, no, well, let's leave it like this. Content disposition value. Yeah, it's fine. It's fine. We explode it. Take the first part is the name. Take the second part is the value. Content disposition name. Let's leave it like this. Key and value could be. Key value. If key equals name, value. If key equals file name, value. And then PHP is a bitch, so we will unset key unset value, just to be perfectly sure nothing bad happens. Content disposition value is not a word that we're scared to be using down there. But the problem is that when you define a variable inside this block here, the scope won't be this block, will be everything from here onwards, so or downwards if you prefer, reading from top to bottom. So if you don't do this, from now on you will be able to refer to key and to value, and they will have the last value they had inside the loop. So for the last loop, they will assume some particular value, and the last time there's an equals in the content disposition value actually, and then you will carry on. And so if you use key somewhere else, thinking about a key you defined out here, and you didn't realize you defined another key here, which in a normal programming language would just shadow the external one in the internal scope, but then when you get out you still see the original one. No, this one didn't only shadow, it overrode the original one. Bad thing. Very, very bad thing. So what we'll say is that the content type is handled, the content disposition is handled, and we really don't care about anything else, because this does what it's supposed to do, and this does what's supposed to do, and moves us to the reading body state, where the things get interesting. Because when you read in the body, you can say if current part meme type equals text we actually define the text body and then do this. But first we have to get the chunk, and we won't use fgets as we saw before, but we will use stream get line stream, and that's where things get interesting, because we will definitely have to keep account of the bytes we're reading. Actually, let's do this. Let's comment this out and check if we got the first part right. So, while false is not good anymore. Oh, damn. This is dangerous. I'd rather have it the other way around. EOL found. Let me drink some spicy water, which is not spicy, it's just regular water. Because if it was spicy, I would have been burping flames in the microphone. That's not healthy for you in particular. This This should stop the parsing. And so I'd very like, well, let's do it. Log debug JSON encode the object we created. So current part. Oh, well, not really. Yeah. Yep. Let's go. Unexpected variable key, line 96. Why don't I remember to... yeah, because we forgot this. Why don't I remember to just give it a run here and see if everything's fine before running the code? Which is something a compiled language with a normal brain would do. But I guess this is what you get for using PHP as if it was C. I'm struggling a lot with conditionals. I undefined array key, base graphics write file in file HTTP data online. Yeah, well, not concerning. I just want to go here and see if... No, it didn't work. Why didn't it work? I really need to build a good debugger for PHP because based on Xdebug actually. Sanity check. Passing here. Log debug. Started doing. Reading a header. Log debug. Found empty new line. Let's do this. And let's see. Let's do this. And let's do that. And let's do this. And let's do that. And let's do this. And let's do that. Let's go. Nothing. So the problem happens before file HTTP data online. Undefined array key in... are we returning before time? What did I close? No, stupid Windows. Stupid Windows. What's SRC multi-part form data? Here, here we are. Nothing at all. Parse boundary string. Here we get here, right? First line initial log debug. It was working before, right? There's some problem here. Initial boundary string. I'm sorry. Is it just like this? Are you kidding me? Actually, probably the problem is we have the look at this. Look at this. Expected first line should be this and this. And if first line is equal to expected first line, else we will do this. Expected, no, not expected, first line. We were expecting expected first line. Yeah. Let's see. Better because it changed. Yeah. In fact, we fixed it because look at this. Parsed boundary string, passing here, started doing, reading a header, started doing, reading a header, started doing, found empty new line, started doing, and then it came out and it printed this, and this is actually the object that we needed. It has headers, content disposition contains from data, name equals base graphics from file name, content type image JPEG, and then the meme type actually was parsed correctly, so it's row image JPEG, type image, subtype JPEG, additional details null. The name has been parsed correctly, the original file name has been parsed correctly, the text body is null, the file handle is null because we didn't finish. But looking good, looking way better before actually. I was confused before probably when I did this, and so I took the worst route. This time is the better route. I like much more how we're doing things here. So when we're reading the body, we will get a line. The problem is we now have to start to keep count of where we got. So byte counter, and we start from 0, and we could do this. Look at this. First line fgets put data byte counter plus equals strlen of the first line. If first line equals expected first line, blah 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 blah. Then every time we call fgets, which is here, strlen line, I'm thinking, yeah, well, not a problem. I must hit myself on the head and say, no, you're not solving that problem now. I don't want to linger anymore on the fact that this thing and the fact that we do the fgets here is how to say, not elegant. Okay, don't care. It works. Fine. We'll have the time to get better in the future. Get back on it in the future. We were saying that we have to increase the byte counter. So the moment we reach, well, actually, we're doing it every time. Yeah, perfect. So the moment we reach this point here, log debug, byte counter says string byte count. Well, actually, it's implicit byte counter. Okay, and Then we get a chunk and say that the byte counter has to be increased by strlen chunk. We don't do anything else. We just want to... Oh, well. Wait a sec. Let's take a chance here and say if byte counter more than or equal to, how's it called, content length, the parser state is set to EOL found. Then we'll have to go down close the, yeah, well, okay. This one is not needed. Fclose return parts, yeah. Let's see. We're taking a chance here, so. That's it. Line 121. Oh, right. It's not stream, is put data. Let's go. 131,000. I think we have to print the last one. Yeah. So we'll do this. Log debug EOL found. Byte counter is byte counter, which we'll already see. And content length is content length, just because I'm lazy and I don't want to think. I'm already thinking too much and making a lot of mistakes, so let's have the computer tell us if everything was fine. Right, perfect. So we are actually able to say if we're gonna finish or not. And just to have another sanity check, let's chunk length strlen chunk and then say log debug chunk length. It will just sheet a lot of numbers in our console, but I don't care. It didn't. Why didn't it? But because that log debug is trying to print something that's not a string, actually. So strval, and let's go. Let's go ski. Here it is. You see? It's always 8,192 until it isn't anymore. When it isn't anymore, we know you got to the end. We have to be very careful though. So we have to check the byte counter actually, because if adding the chunk we get over the total size less the size of the last line, yeah, that's delicate. Look at this. The fact is that we say expected last line boundary string. This is it. Okay. So there shouldn't be a new line after this. I don't necessarily expect it to have a new line before this. Okay, I said boundary again. That's it keeps happening. It really keeps happening. So I could say where is it? Here. Well, actually, we have to go back to the top and say expected last line length equals string length of expected last line, right? So now the moment we know we have that information, we can say, let's check where we got with the byte counter right before getting another chunk, right? Let me draw, because that's what I do in this situation, not to fail with designing the algorithm properly. And that's what I will do right now as well, if I find my Wacom tablet, which is here on the bottom of my lovely rucksack. Also called backpack, because it's a pack on the back. Come on. Software engineers never being good at finding holes. That's the truth, everybody. That's just the truth. Indisputable truth. So, new image. Create. This is okay. It's already stuttering. Let's go. The stream of bytes will be like this. Okay. This part here is the last line. We can have a series of situations. We can have the last iteration start from here. So actually, well, would be better if I did this. Okay, here, this byte, or here. This is some random byte before we start the last line, okay? The last line starts with this byte here. This is the first byte of last line. I call it last line, but it's the separator actually. So I should call it the separator. But if we end up here, we will have to check that. We of course we know the content length, the bytes counter. The bytes counter will say we have n bytes, right? So it says this chunk here is less than 1192, but is bigger than last line length, right? So if we are in this situation, we are here. This situation here is the last chunk is not only less than this, but it's exactly last line length, last line len long. Okay? This is the most worrying situation because we don't want to end up in this situation. So we'll have to start doing things differently when we are in the previous iteration before this. Okay, because this one is the last chunk is less than 8,192, but less than, also less than last line len, right? What happens here is that I can recognize I will get into trouble, I will get into this situation if on the iteration just before we have that the difference between the target, which is called content length, right? Is content, yeah. We know how much it how much we have to go, how many bytes we miss to the end. Not we miss. Yeah, how many bytes to go there are. So we can compute that because we have the content length. And if we do this minus the byte counter, I don't know how to write, this is bytes to go. Okay, so bytes to go, we could divide them by 8192, okay, and actually take the modulo, so we have the rest. The rest at some point will be less than actually it will always be sorry, wait a sec. When we divide by 8192 and this is equal to 1, it means that we have one full chunk before getting the last truncated chunk, the last chunk which is a little bit shorter, which may be this long, exactly this long, or this long, okay? So when we divide and we find it's 1, we also have to take the modulo, so we have to do this bytes to go modulo 8192. This thing here is the rest. If the rest is larger or equal to last line length, no problem. We will just parse it. If it's less than that, we have to stop before, so we will have to take a substring right now. So let me make it more clear. Three situations. 1, 2. I'm getting lower and lower. And 3. Here the file actually ends and there's the separator, right? So the last line. We can have the iteration finishing here, the previous, the penultimate iteration finish here, way before the boundary, here on the boundary, or here in the middle of the boundary. Okay, we can do this and say, if I take the difference between, I take bytes to go, divide by 8192, and this equals 1. And this is true for all three these cases. So I should actually have put this here. Where is it? Here. Here. Because it's true for all three cases, actually. Okay. The difference is that here, bytes to go modulo 1, modulo, sorry, 8192 is less than last line length. More than last line length. Because this is what this measures. Okay, we're still working on these bytes, so we just use the stream get line to get these bytes. We are pushing them into our file. Actually, I think we are concatenating them. We should we are not doing anything with them, but we should call fputs. Where is it? Fwrite, yeah, which is the same. It's an alias. Fputs it's an alias for fwrite. We should call fwrite and write down the chunk time by every time. Okay, so we are just writing this chunk to the file, and we find that the next time we will hit the end of line, because here end of file, sorry, we will hit this. Okay, so we will simply care about this in the last iteration. This is bytes to go modulo 8192 exactly equals last line length, and here you know what? I'm thinking that there must be this here. Because otherwise, how would it work when I... yes, there is certainly there is a new line here. How would that work in the previous case otherwise? We were using fgets. Fgets will split on lines. So there must be a new line just here, just before the last line. Okay, so it's 2 characters actually. Okay. Okay, this is a nice information to have. And here, bytes to go is too little. Less than last line len, right? So in this situation here, we must know then next iteration we have to do what? Take the last part which is, and all these bytes here must be taken and we must give them to fwrite, but just those bytes before the entire chunk was going into the file. Before, I mean in the previous iterations. So write, not writer. So we'll just have to take the bytes to go length, which is now this. Okay, bytes to go minus last line length minus 2, I guess, because these guys we will see if we corrupt the file or not. Let me separate this part. This should work, because if you do a substring with this, we're fine. In this particular case, we already wrote all of these things here. Actually, we could treat this as the corner case and say equals last line length minus 2 minus plus 2, sorry, and plus 2. Right? Let me pick the blue here and do this. So here the next is also last iteration. Here the last iteration actually I'm thinking we could avoid doing substring and stuff like that. Oh well, no, it's better to go this way, because I was thinking that if a small chunk remains, we can just go with fgets, but nobody says there's not a new line here as well. So nope, I don't want to take the chance. Last iteration, we'll simply check that the last line equals what we expect it to be. So /r/n and then minus minus and then the string and then minus minus. Okay. The string is the separator. And in this case here, the penultimate iteration must look like this. So penultimate iteration must look like this, and but also saving also this must be checked, like here. And the penultimate iteration must also be saving the first chunk of the end of the file here, the file of the request here. We have a working plan. Now we have just to check if our understanding of what's going on and the code that we are writing is right. So we will actually implement exactly the same variables, which are bytes to go equals what's it called, content length minus byte counter. Now that we know the bytes to go, we have to determine if bytes to go is divided by 8192, which we could also put here so that we are sure that one can read this code and understand what's going on. If this division gives us more than 1, then we are still in the middle of the reading. So we just do this, we just do this, we just do this, and we f write. Okay, this if will be a kind of a performance hit, but sorry, must be here. We could actually do this before going to the next state when we're here, if we determined that the content type is not text, right? So let me see. Text, current meme type is text. Yeah. Let's go like this right now and say if current part meme type, what's that type? Yeah. Where was I? I have no clue. Here. Type equals text. Then we do this. We create the temporary file we will write to. Okay, I'm cooked, guys. Okay. That's it. We do it right away, so we don't have to do that check every time here. We already have this if to do every time. So this goes away and this stays. Else, if, I mean, it can't be 0. Oh, well, else. It's the it's either the penultimate or ultimate or last iteration. What do? We say, okay, let's compute bytes to go modulo this, right? Let's call it like this, because when you do, actually, when you do that, you're computing how many bytes to go you will have the next cycle, the next iteration. Future bytes to go, right? Those are the future bytes to go. If future bytes to go are less than equal to or more than what we said, last line length plus 2 we could say just to make it a little bit more readable, last I have an idea. Yeah. Before last line, which actually makes it a last line officially. We could have a third state, which is reading last line. So what we can do is say, well, this final bytes length, which by all means we don't have to compute it here. We can compute it here at the beginning. Length, I really can't spell length correctly. Is it right? Oh well, I could just do this and get rid of a problem. semantically it's not right. So let's do this. Final bytes length. I don't like that name very much, but what can you do? Final bytes length. We can do, in this case here, we can simply write everything we have, because the future bytes to go that we will have in the next iteration will be exactly those that we don't want to put in our file. So here we do this. I'm thinking, do fgets also? Yeah. Wait, do you remember? I said at a certain point I said that here we have the carriage return a new line, and said, well, we want to leave them outside. Actually, I guess we want to take them in, because when we were using fgets returns the string up to the carriage return a new line, including the carriage return a new line. And we were doing that to the file, and it was working. So, I spotted the bytes length. Final bytes length actually must go, and we will work with this, and we will dump the last new line to the file. We can experiment with that, but right now I'm positive that we should keep it in the file. Probably a new line at the end of the file is either expected or not that harmful. Let's say we do this. Let's see if this thing will bite me. Bite me back. Where is this one, which we checked and was fine? Copy. Cat. Yeah, if I go to the right folder. Okay. There is a new line. You see? Well, actually I'm not positive. What the hell? No, please. Don't do that. Do it again. Why is it leaving everything in this state? Okay, I won't ask any question. Let's try one way and the other and see what happens. F-write. Well, let's see. Chunk. Stream get line. Put data 8192. F-write. Current part file handle the chunk and set the state, which is called parser state, if I recall correctly, to reading last line, right? If it's less it's a problem. If it's more, we can, if it's more, we can just do what we did. Oh, wait, I forgot one thing. This. If it's more, we can dump everything, because bytes to go divided by 8192 just gave us 0. No, it could have, it could be 1. Yeah, it's 1, probably. The first time it's 1. Wait a sec. Bytes to go divided by this is 1. Yeah, the first time at least. And if future bytes to go is more than, which means we are in either this, or this situation. It's not this because this we handled. It's not this because this is the last one I want to handle. We are in this situation. So next time we will have still to do the thing, which means now we can dump everything. So chunk stream get line put data 8192, and the same goes for this and this, and simply then we will find in a situation where bytes to go divided by 8192 is not more than 1. It's exactly 0, because it was exactly 1 when we were here. Now we finished pumping this data. We are in the last iteration. The last iteration looks exactly like this, actually, because what we're saying here, the moment we divide. No, actually, bytes to go are less than. Let's do this. Then just in case, I will compress it down later. I will refactor. But let's say bytes to go divided by 8192 is exactly 1, and then else. So if it's 0, well, I could have saved myself a trip and just do this and then do this again, but with a different number. Yeah. More. Well. Chunk stream get line. So what happens is we are dealing with this last iteration now. So we want to say take the length is less than the regular 8192, subtract what we know is the end, and dump what you find, a substring, to the file. So we will say bytes to read equals bytes to go minus is there a viewer here? If there is a viewer, show yourself if you want. If you don't want, don't show yourself. You can just lurk. By the way, I'm parsing put requests just to give you context on an e-commerce. People can upload pictures to this e-commerce because they can print it on a product, on different parts of the product, and when you're uploading the file for the first time, you're using post, and post is perfectly handled by PHP, but on the second upload on the same side, you have to overwrite the file, so you will have to use put. This is a choice I made. I could have used post anyway and get on with it, so I could have simply overwritten the file, even if semantically post wouldn't mean that. Post should always create a new one. But I could have said, well, I received a post request. Is there a file? Yes. Then I rewrite it. Is there no file? Well, I simply create it. In this case, I'm going with, if I receive a post and there's already a file, I give you an error because you can't create more than one for the same section. And at the same time, if there is already one and you use post, I must handle the file correctly, but PHP is not handling it, so I have to read the content of the request, which is I can't find it right now. Well, you can see it from here when I do it. Let's try. If I do this, now it's broken, but still the request has gone down to the server, and this is the request, and we are parsing the headers one by one, and then parsing the body. The body has a variable length depending on the file you're sending. Then at the end, there will be a new line, and then this thing here. We are trying not to put this thing here at the end of the file. We want to close the file just before. So we are handling three situations where now we are writing down to the file chunks after equal length chunks until we get to the end. The equal length chunks are this long. There's a reason. We don't care now. When we reach the end, we notice because we are missing less than or equal to this quantity of bytes, so we want to stop just before. And we have the situation where the last full chunk stopped us here, so we know that the last chunk will be a little less than this or equal to this. Now I have a problem with that, but I will fix it later. Or we stop right here on the boundary. That means just here, just before this dash here, or it would take us way into the separation string, which is not what we like because we already failed. We already pushed bytes that we shouldn't have pushed down to the file. So we are trying to detect all these situations and avoid to do disasters. So this means we are dealing with a full chunk, because if you divide the bytes to go with which is the content length, which you know upfront, by the byte counter, you simply know how many bytes you have before getting to the end, and if those divided by the normal chunk length are more than one, you're fine. You're dealing with a chunk that's still in the middle. When it becomes one, it means that the chunk you're dealing with is this one. It may be exactly 8,192 bytes, which is, I mean, improbable, but it can happen. Who cares? you still know it's the last one, so it has unwanted data. This is bad. This, oh, sorry. This is data. Why am I using this instead of the technology I have to draw? This, you don't want it into the file, so we have to avoid dumping it, writing it down to the file, right? So, warning, we don't have to treat this chunk like the chunks before. If this chunk is even shorter than 8192, will still be captured, because this says the bytes to go, oh well, it should be 0 actually. Well, yeah, so this should just be else. I'll show you why I went down this road. Because actually what happens is, in this situation here, you're already too far, so you want to be warned against this situation one iteration up front. So this means you're handling the penultimate iteration. Okay, if you're handling the penultimate iteration, you should write everything down, just if the rest of the bytes. So it's the penultimate. It means it ends somewhere before the end. It could be way before the end, so the bytes to go in the next iteration will be more than this, which is this situation actually. So you compute the future bytes to go, the rest, the remainder of this division here. Those are the future bytes to go, the ones that you will care about in the next iteration. If the future bytes to go are exactly this, you are very lucky. You're very lucky, because this iteration will just take out the bytes that are meant to go in the file. So you write them down, okay? You get them from the stream. You update the byte counter, because I'm keeping a counter to be able to do this. You write the chunk to the file, and then you move the parser to another state where it will handle the last line. So this is done, and it's this situation. This situation here is the one I'm dealing with right now, which is, okay, well, let's do this. I'm writing, even if I write the entire chunk I'm handling now down, I'm writing up until this point. I'd rather also take some other bytes from the stream, so these bytes, write them down, and then go to the last iteration, which will handle the end of line. So what we do here is get the chunk, the entire chunk, compute the chunk length, update the byte counter, write the chunk, then we should be here. So we have two choices. We let the loop go through, and we will not end up in this branch anymore, because bytes to go divided by 8192 will return 0. We return 0 because we are here, and we already determined that the thing that we are missing here is less than an entire chunk, right? So we could handle that in this else, which was the first approach I was taking. Or we could say, why not compute what else we're missing, get it from the stream, which probably I prefer. which probably I prefer. But I prefer it, but it's maybe a little bit more brittle because I could have, well, if I introduce the bug here, we are doomed. We could finish in that situation somewhat differently, okay? And it's not handled because there's no else in that case. There's just this or this, and I'm just relying on the fact that I did everything right. So we could write it here and say the bytes to read are bytes to go minus the expected last line length, right? So we read just those bytes there, put data bytes to read instead of 8192, right? And then we sorry, I forgot. I will refactor this to try to avoid all this duplication if I can find later a way to make it more concise and more elegant, because it's everything but elegant, this thing. If you don't have the drawing I made here, you can't understand this code. It's very difficult because it's very arbitrary that I put this if, this else if, and this else like this. It's very bound to the graphical representation. So if we can find something that's a little bit better. Let's first write it down, see if it works, plant a flag in the ground, and then we will move from there. Current part, that's right. So here we write to the file handle the chunk and set the parser state to reading last line, which will make us not enter this case, but actually one that does not exist at this moment, in this moment, which is reading last line, and we will implement it later. Break. Oh well, I like the break to be here. So this should take care of this case. So now we are left with this one, where we know that already in this chunk here, because if we get a chunk that's 8192 bytes long, we will end up eating a part of this, and we don't want that. So how do we fix that? We say that we want bytes to read should be 8192 minus the difference between the expected last line length and the future bytes to go. Because the future bytes to go is this part here, right? This part here is the part of the last line, the part of this line that we are not able to eat by mistake, even if we want to, because we are going to take in at most 8192 bytes. That's our rule. I decided we go with that fixed size, okay? I actually figured out a better way to do all this, but I will tell you later. So the part that we risk to ingest by mistake is this part here. Since the entirety of the red part is expected last line length bytes long, and the blue part is future bytes to go long, if we take the length of the red part minus the length of the blue part, we get the length of the orange part, which is what we want to do. So if we take the length of the chunk, yeah, the length of the chunk that we're gonna read, which is this thing here, up to this point, and reduced by, oh, there's another viewer, and reduced by the orange part, we actually get to read just the part we wanted. So this should work. This should work. I'm pretty positive that then it will break terribly. Bytes to read. No, sorry. Put data and bytes to read. Put data is the name of the stream we are reading from. This should be our chunk. The funny thing will be to test this, because I will have to craft files that end up in all the situations and see if they get uploaded correctly, but that's a problem for the me of the future. Chunk length, well, let's copy and don't be silly here. We write that down, and if I'm not mistaken, now reading last line, right? Yeah. So if you see what I mean when I said before that I will have the chance to refactor this, there's a lot of repetition. The only things that change here, I could go like this and say bytes to read 8192, right? And say bytes to read. So this and this are now the same. This part and this part are the same. So I could just leave this in the if and put this outside if there wasn't this else, which doesn't do this. But there's actually a solution for that, because do you remember that I said that I wanted to either read everything here or read a part here and then rely on the loop to send me here? Well, I just thought that I could simply take a little bit more than 8,192 bytes here and read the part that I miss, because in that case I would have very better code, which I can refactor better, and no problem whatsoever, because this number is completely made up. I mean, this number is what you get if you call stream getLine and put here a 0, which is by documentation stream getLine, as per the documentation, the default socket chunk size, but actually you can read chunks that are longer than that. It shouldn't explode. I was just trying to read fixed size chunks, not to incur into a very long chunk that makes the memory explode. If you read a very long chunk and you're already using with your PHP process something like, I don't know, 125 megabytes of RAM, I don't know why it should happen, but it could happen, and then your chunk is 4 megabytes, you're cooked. The process will crash with an error, because you you went over the maximum size for your process, which is 128 by default. So I want to deal with small chunks all the time. But even if that chunk is a little bit bigger, so that I can get to the end a little bit faster and avoid jumping through the hoops with the code, I can do that. So I think I will do that later. But let's just try to say minus log debug equals, just to see, testing with a real image where we end up if this thing works. And this we expect to happen just after this. So solitary else. This thing here has to go. Actually, byte counter says was interesting to keep. Let me say byte counter says, byte counter says, byte counter says, byte counter says, and byte counter says. And at this point, we could even this should happen. This shouldn't happen anymore. We leave it just to check if it happens again. And we could definitely, I mean, I will implement something that checks if the last line is what we expect. Check if the last line is exactly what we expect. But for now, I will just send parser state EOL found. So we will just break out of the do while loop. That's the first time I write a do while loop in 5 years, I guess. Okay, I'm nervous now. Let's try. Let's say I load this very small image. Yeah, sorry, I always forget to check the syntax. 172, of course, it says so even in the browser. 100. What's wrong with you? There's nothing wrong at 172. Unexpected. Why don't you expect a semicolon here? What did I do wrong way before that to make you upset that way? This is okay. I mean, am I not seeing something obvious? By the way, it entered here. No, sorry, not real. Not real. The parsing happens up front. I really don't understand the TLs on line 180. Line 180. I guess there's something wrong. This is okay. This is okay. This is okay. Is this okay? Yeah, this is okay. Okay. Fine. This is fine. This is fine. Is this doing what I expect it to do, right? This is fine. Fine. Sorry. Excuse me, what the hell? Keep saying that. Let's try delete line 172 and see if it's more explicit about what's wrong. No, still the same thing. You're pissing me off big time. Let's comment everything here. So the problem must be here somewhere. Am I? Wait. There's some stink there. Modulo operator PHP. Tell me there is a modulo operator. There is no modulo operator. There must be. Yeah, there is. Of course there is. So that's not the problem, right? Or is it? It's not a problem. So the problem is after that. Oh, God. That was terrible. Okay, 178. Yeah, of course. That's right. Okay. Yeah, this is what happens when you program nonstop for too long. Let's say we try it again and see if it works. Null given. Online. Where did you go? 186. Why is it null though? Did I write anything? Let's see what happens here. You see that byte counter says this. Oh, well, no, that was the file that we were reading before. Let's take a bigger file for a moment, and then we will see if the smaller file gives us a problem. Let's take this one. Okay. Nope. We should be getting here for most of our time and get much more than one print. First branch. Where am I? Here. Let's upload the picture and see what happens. First branch says this, and then something bad happened. Why? F right, argument 1 must be of type resource, now given line 140. So current part, okay. Sorry about that. I thought I fixed this. If it's different from text. Yeah. Silly error. Here we go. Okay. We didn't break loose. Wait. I want to know. That's the risk when you get to work on a while loop. It's always in the first branch. Why is it always on the first branch? Because am I dividing the wrong thing? Bytes to go. Content length minus the byte counter. They should be less and less, right? Bytes to go. And then division. bytes to go divided by 8192. Yeah. Let me see. I did 200 things, and it's normal that at some point didn't I? Wait a sec. New request. Oh, right. Sorry, I didn't mean to. Sorry. That's not okay. Brain fart moment. Stop it. Okay. I'm stopping it the wrong way. I have to refresh the page. Okay, right. I'm assuming. Hello. Where's the first time chat from Mandy? I don't know if the message came right now. I was a little bit concentrated. So if you're still there, just knock and I will answer. I will keep an eye on the chat. The bytes to go, the division in PHP, actually, even if it's the division between two integers, I think it will try to give you a float result. You see division, quotient of A and B returns a float unless the two operands are int or numeric strings which are type juggled to int. And the numerator, int div we have to call. I'm reasoning as if it was C, but what we want is int div bytes to go, comma that, and we just miss this thing here. Int div bytes to go, comma right. Also here. Am I right? I should be right. We will find out. Let's see. It's not stopping, so I'm still wrong, but I forgot to start the server here to see what the browser is. I mean, what the backend is vomiting. So I couldn't see anything. Let's stop him because he's still going. Why are bytes to go this big? Byte counter says 4. Actually, I should let him go because probably it's very slow now that it has to print this much. Let's try to let it work. Pending. What's going on here? Not what I expected. Just wait a sec. Let's try. Let's do this. Let's try again. I will. Oh God, there's a lot of stuff in the. You see, it's keeping. It keeps getting here. It keeps arriving. How do I handle this? And also, is there any chance I have still some division around that I don't want? No, shouldn't be. So why isn't it stopping? Man, please stop. Can you please stop? Seems so. Are we confident? We are confident. How big is this file? 341 bytes. A little too small. We would need something bigger, but not huge. So how big is this? Still too small. This is too big, right? This is good. $16. Why is it struggling though? I really don't understand what's happening here, because I mean, it says 16. It's still printing out floats. Why is it printing out floats? Oh God. Oh, even this returns the reminder in float, so you need fmod. Ah no, sorry, not true, not true. Integer division returns the integer quotient of the division. I'm baffled. It kept going. What am I missing? Let's say this. Look, wait. I don't want to fight against this one second longer. Sorry, wait. We will do something like this. We will say, are we updating the byte counter everywhere? Byte counter. If byte counter more than I don't know, let's start small and say 5 times 8192. We just skip to the last part. Okay, so that we know we cannot end up in infinite loop. You should stop. You really should stop. What is he doing? I think I will just kill the server at this point and restart it, because we should still see just one request here. So there is something sketchy going on, if you ask me. Actually, let's go incrementally. Let's say we do this and break, right? If we do this, we should see something sane. So, how are you? Looking good. Okay. Again, what are you doing? Why is it pending though? I already encountered something like that the other week, I guess. There was this situation where the browser stopped sending requests. It just became very slow. So I'm very tempted to restart the browser as well. I might have found a way, I might have found, yeah, a way to mess the browser up actually. So who knows? At least the tab. At least the tab. Localhost display case. You see, it was doing this as well. So what if yeah, that's probably it. I didn't expect it to happen again, but it happened, and I sure don't like it. I will have to investigate that thing. Okay, we're back in business. But of course we didn't reach any of those prints because I broke just before. So let's do this instead. No, wait, it was post, so it was a post request. You can see that the first time it's a post request. So we have now to override the picture. Line 231, where is it? Log debug must be type string bool given 231. What did I do wrong? 231. JSON encode current part, and this must be string value just in case. Or is it before current part? Why wouldn't the current part be ready at this point? Oh, maybe because I cannot yeah, because there's a binary file which is not serializable. Well, okay, this actually is good news. Perfect. Okay, nice. Okay, that's okay. So if I now take this away, it should be able to write at least some bytes in the file. I did a stupid thing, but it works. Byte solitary else. You see, if you have a very small file, that's the situation I was very scared about, to not have considered all the cases. If you have a very small file, the entire file will be less than this, right? So when you make this division and you have bytes to go that is less than this division straight away says 0. So it's not this, it's not this. You are doing this, right? So you have to compute the bytes to go, the bytes to read that chunk, write it down, and then move to reading last line. If this worked, because it printed solitary else, so we know we went down there. You see, division was 0, bytes to go were 735, so we had to read a very small file. And actually, it's a little less than 375 bytes, that file there, because it should be, at least. Let's see. If I go and check that file, which should be here somewhere, image. Here you have it. It was this one, right? Let me see. No, question mark icon. This one. 341. No, 689. 6, 8, 9. Properties. It's 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8, 9. 6, 8 and it said it was 735. We can just check manually, because we know what the line, the last line was. It was, where is it? Where is it? It's here. No, it's here. Show me the source. This thing here is completely ASCII, so it's as long in bytes as it is in characters. Let's open a new tab, print this thing here, and this is 42. So let's say we take the bytes that we wrote here, read here, 735 minus what did I say? My memory is going 42, which is the answer to the universe, and 693. Look at that. Not 69. What am I missing? Is there a new line in the middle? A couple new lines. Yeah, it could be a couple new lines. The new line at the end of the file and a new line. If that was the case, it would be 4 characters, which is carriage return, new line, carriage return, new line. So /r/n/r/n. That would work. Also, let's get to the actual upload folder and see if the file is broken or not. Not the size, but the date modified I'm interested in. Should be this one. Property 1 kilobytes. Yeah, well, right. 693 bytes, which is what we wrote down, which is a little bit too much. But let's see if the last couple new lines actually are a problem. Open with Paint. we did it, even if it's ignoring the new lines at the end. It's just ignoring them. So it would be fine this way too. But we're perfectionists. So we now know that the computation must... the easiest way to do this is to go and say that expected last line length is actually something like this, which is something I already did before, but then decided against it. But let's try it just for the sake of it, just to see if it works and how it works. So let's go here and do that one more time. It did something like, I'm in the complete pitch dark. Wait a sec. It's blinding me, but at least you can kind of see me. Yeah. So what we were saying is that there should be another file here now. Is it true that... yeah, okay. It should be a little smaller, 689 now. Yes, it is. And it should still be the same. Yeah. Yes. So my assumption was kind of correct. To be 100% sure that I'm right, I could do this. Look. I could say, where is it? Where is the else here? we write this, and then here we actually do this log debug. Let's be very greedy. Let's say that we just eat everything that's to read here. We could do this, look. Better. Log debug, chunk. And of course, this will not work the way we expect it. I mean, it won't print the carriage return and line feed as symbols, as characters, but it will print them as carriage return line feed. So we should find that log debug starts here and goes one down, and then writes. So there should be one empty line in the middle. Let's finger crossed. Let's cross our fingers and try it again. Syntax error. Matthew. What the hell? Why? What's wrong with you? Unclosed. I didn't save the file. Yeah. Beginner error. Let's do that again. Okay, and let's see here. What? Did that kind of work? Let's see. What if I well, I'm very curious. I'm very eager to make it work. Yes. Yes. But also no. There's a new line after it, and there's just one new line before it. So what the hell were those couple bytes we didn't see coming? We have to print them. We have to convert them to hexadecimal. How do you say it? I'm tired. And see if they are something we didn't expect them to be. We could go like this. We could read 4 bytes. Log debug. Wait. How can we do this? Each one of those, I mean, can I access? Yeah, I can access each character in the string separately with this notation, right? Getting single characters from strings. I never do this. And I forgot how to. Not substring. It's treated like an array. Okay, perfect. This is what I wanted. So we can go and say chunk 0 up to chunk 4 to 3, right? And bin to hex, I should have done that before. Yeah, and log debug them, right? Maybe if I prepend a string that says byte 1, it's more recognizable. So byte 1, byte 2, byte 3, byte 4, byte 1, byte 2, 3, and 4. And then we can do this and this, and this should be the last line. Let's try. Zero D, zero A, to D, to D. What the hell? Let's find an ASCII table. ASCII table, Wikipedia. She is the one. 0, so it's 0 D. Sorry, 0 and it's D, so A, B, C, D. Carriage return. That's okay. 0A. Line feed, so there is a new line there. Carriage return, line feed. And then to D, to D. Yeah. Oh, yeah, right. Where is it? Yeah. Okay. This is 2D, which is a dash. And this is why. This is because I'm looking at the length. Yeah, actually, the length of the expected last line. It's like these two were a little bit too much, because boundary string, look at this. Let's do this manually so we can't make a mistake. If you go to the headers of the request, the boundary string is this one. Okay. Copy. Let's paste it here, which you can see is missing. I mean, the guys at Google, when they programmed the Google Chrome browser, decided that this string here must start with dashes. But the protocol says let's start with 2 dashes and then have a string, okay? And then we will put it at the beginning of the request, and then at the end we will put the same exact thing. So let's get rid of this. Oh, actually, let's put it here. We will have the rest of the body, and then this and this at the end. Sorry, like this, right? Something is wrong here, because it should be, yeah, like this. Okay. So actually this should be the case. Okay. This is the separator. This is what we find at the beginning, and this is what we find at the end. Right? So there must be some stupid error with the length here, because the expected first line is this. The expected last line is this, but it actually has, we saw, a carriage return and a new line even at the end. So I'd rather do this and say that the expected last line is what we actually expect. Assume there is a new line just before and discard it. And probably she also has 2 bytes late after, so it's probably like this. It is probably like this. Expected last line length. Let's say we take this and increase it by 2. It's probably right. Then I will make it better. Right now, I just want to check if my assumption is correct. Because here, bytes to go minus expected last line length minus 2. Or plus 2, but we put it inside the parenthesis. Then, when we print the last line, yeah, there is the new line at the end, of course. And there must be a carriage return and line feed just before. These two should go in here, and we should have 6 of them. So, new try. Not really. Why are these two not? Well, that's my fault, actually. That's actually my fault, because I should have been well, I didn't save, first of all. Second, I should read just 2 of them. Yeah. Let's go. Let's go. 735 minus, why do I have 2 calculators? 735 minus 42. No, again, that's not right. But it should be, because there's a carriage return, new line. So what if I... There's still something missing in my head. Hello. I see 2 viewers again. It was 1 viewer just before, and now it's 2, so it's not just me. It's the final debugging session of tonight. I hope I'm there, because the file is getting uploaded correctly. The size is the right one. The size is the right one. And actually, no, sorry. Everything's fine, because 735, and then we have to take away the length of this, not 42, the length of this, which is 42, plus 4 more bytes, which are the line feed and carriage return just before and just after. So it's 46 actually. So you have 375, which is something that we got printed here. We had 735 bytes ago. minus 42 minus 4, and it's 689. So wonderful, it's working. Every single byte is what we expect. We can even be so yeah, okay. We could even be so cocky that we say assert that this, not assert actually, but we should be able to check that the last line is exactly the same as this here. Yeah, this. Right? So the fact is that here, doing this, we are eating an empty line, which is why before when I said chunk f gets, and then of course I put data here, and then I wrote log debug and chunk, it was printing an empty line because it's these 2 bytes here, the carriage return and the new line. So everything is perfectly fine. This, it's a new line, and this, so there is a new line at the end. Because if there is a new line at the end, just before an empty line before the last line, this thing here becomes a lot simpler. Because I can show you. Let's make a new file here. Create. And this is really the last thing. I will stop it here after this and go to dinner actually, but I will continue probably on Monday. I still have to decide. I probably want to make a what it would be a morning session here, but it's not a morning session here. I mean, yeah, it's a morning session here, but around the world may be in a better moment of the day. So I don't know. I will think about it in 5 minutes. Why am I drawing in purple? Black is the color. So 3 situations as usual. 1, 2, yeah, no, this is not good, and 3. With the part that we don't want to get, which is let's say the how do you call it, the divider here, and here, they are actually the same. Okay, there is a couple bytes just after, which is the carriage return and line feed. These are 2 bytes. Okay, the same happens before. So what happens is that you are somewhere around here at the beginning, and you still have to read the end of the file from the stream, right? So your pointer is somewhere around here. And the part that you're gonna read could be this long, or you may have the pointer exactly here, so that 8192 bytes will end up eating the file up to the new line, or you're here and the chunk is too big. It would phagocytate. Is it a word in English? I don't know. I think not. Phagocytate. No, it's just Italian. It's just eating. It would give a bite to the forbidden fruit here. But the fun fact is that if I can, and I can predict when I'm in this situation, being that here there's a carriage return line feed, okay, I can just switch to fgets, which will actually eat also the carriage return line feed. So we've already seen that it doesn't do anything to the file. The file works perfectly. The carriage return line feed, it's ignored from the end of the file. But I'd rather have the true precision of saying I strip the carriage return and line feed from the end of the file. So yeah, no. But still. Next time, oh, perfect. 21 and 29. Next time we will deal with cleaning up this code, because it's first of all we will deal with testing also these three situations, because we just tested this one, but now I'm confident that these three are working more or less. Then we will see if we are able to refactor it properly. So it is a little bit more elegant than this, because this is like really poking at a single specific situations, while we could you see, this situation leads to having this situation, which is like having a very short file, which is something we already tested. We already tested that which is this one, will naturally solve itself, because it will end up doing this. And then these two are, this one is this one, and this one is this one, where we kind of truncate. Here we are not actually truncating anything, but you got me. Yeah, you actually say at the end, jump to this other case, because if not, you would come out, go here, bytes to go would be 0. Would be exactly the same amount of this. This would be 0, and so not good. Even if we move this check up here, yeah, it could work. Well, we have material to work the next time. Next time on the schedule should be at this hour now, but on Monday. So Central European time it's 9:30 p.m. But on the Eastern time it should be 3:30 p.m. and on Western time it should be Western Pacific time it should be midday and a half. But I'm thinking about making a live streaming at what is 7 a.m. Central European time, which would make it 10 p.m. For the Pacific time. Yeah. And that would mean 3 hours less or more. So 1 in the 1 a.m. for Eastern time. yeah. I will try that. It's a little bit bad for Eastern time, but let's try that and see how it goes. Not 100% sure I'll be here at that time. I'm 100% positive I will do the stream in the evening. So follow the schedule, and maybe there will be one more live in the meantime. And I don't know if I will touch this because maybe I want to keep this on the official schedule. Okay, thank you for joining me, whoever passed by. Thank you for watching it. I had fun, and I hope to see you in some other stream as well. Goodbye and good night if it's the same. So Mandy was watching. Hi Mandy, you followed now. I know. Let me know in a message if you want. If you'll be here on Monday, and which time zone you're in, so we can compute the time. Because I'll try to. I mean, you're my only viewer in this moment, so I will try to accommodate whatever time is better for you. If not, yep, I'll be there. Okay, perfect. 9 p.m. Like this time, but on Monday, which is the official. Because if it's like this, I will go on with this, with what we were working tonight. Okay, perfect. See you on Monday then. Have a good evening or night or day or whatever. Bye bye.